Class 203 means 73 car management system. You can write any figure, either this or this. So it consists of a microprocessor or microcontroller, okay, which is called as heart of the system or brain of the system. Microcontroller means microprocessor plus some extra devices, memory, some memory, limited memory, plus input output port, etc. It can also have some its own timers, etc. So when we say microprocessor system, means it includes microprocessor and all those extra devices. So we can say microprocessor system means microcontroller. Okay, so we can say it contains microcontroller plus sensors at the input and drivers at the output. These drivers are given to the engine parts, which are nothing but actuators. And we have interfacing, that is input signal conditioning and output signal conditioning. MUP or microprocessor will be taking digital signal and also giving digital signals. So the input signals from the respective sensors have to be converted, will have to be amplified, filtered, and converted into digital values, etc., etc., by respective signal conditioners. You will have ADC, everything here also. And to take inputs from user, we will have separate ADC. And also for displaying, we will have separate DAC. So these things are there. So we can say here mainly 5 parts: sensors, input signal conditioning, controller, output signal conditioning, and actuators. Okay, engine is not shown here. This will go to engine parts. Okay, you can write even this figure also. This is engine. Okay, and here from the engine we will get feedback signals. Okay, here these signals are nothing but these signals. Okay, and what is left shown here is nothing but, sorry, this one, this 1 2 3 are shown here, but here more signals are shown. Okay, there will be more signals even than what are shown in the figure. Now we can say in short that the microprocessor system takes input from the sensors, performs the required control action according to the design, means according to the program stored in the memory of the system. Then it will give the desired output. Those desired outputs are used to drive the respective actuators. Ignition coil is an actuator. So this signal is going to drive this through this. The signal drives. Say this may be converted into analog because this is an analog device. So digital will be converted into analog, and then required amplification, everything will be done. Okay, that is in short. But in detail, there are lots of points. Okay, what each and every sensor does. I will explain few points now because going into every detail it will be difficult for you. See, in a machine, say in an IC engine, okay,
This lateral motion, a piston, a connecting rod, a crankshaft. As the piston travels up and down in the cylinder, this lateral motion is turned into a rotating motion.
see, this is an IC engine. This is the inlet pipe. This is the outlet pipe. This is fuel intake. This is inlet valve, which is held closed by the spring. When it is actuated, this will come down and will get opened. Similarly, this is outlet pipe and outlet valve. In the middle, we have spark plug. At the input, we will get mixture of air and petrol, means fuel. This is the cylinder and piston, okay, connecting rod, crankshaft, and this is the crank. Okay, crank is here, it is part of, it can be wheel or it can actually be a shaft or it can be some any shape. There should be connection between the shaft and rod. Okay, now we need air to be mixed with the fuel because just fuel if we send the fuel will not burn, hence air has to be mixed with the fuel at the required ratio. Then the mixture has to be compressed so that it will become hot. Then spark plug should be ignited. So we should first do suction stroke, means expansion. First fuel should be taken inside, then compressed. While taking inside, this should be open. First stroke. Then while compressing, both should be off. See, now this is open. Fuel is entering. Okay. From TDC to BDC. TDC means top dead center. BDC means bottom dead center. So when it is going from here to here, fuel enters into the chamber. Fuel means fuel plus air at the required proportion. Mostly 2% fuel with respect to the air, I think. Okay, by volume. Now, this is suction stroke, first stroke. Now, in the return stroke, uh, it will be compressive stroke. You can see both will be off. Okay, see both are off now. Now the fuel is being compressed, it is becoming hot. Okay, at the end of this stroke, spark plug will ignite. See, yes. So when spark plug gets ignited, the fuel burns and it is now called as power stroke. The first two strokes, the operator has to kick the pedal. You know, in a motorbike, a person kicks the pedal. So, but from the third stroke, there is power stroke. The power itself will push the piston downside. because fuel has burned now. This power stroke will be able to, is force of this is such that it will force this such that, you see, this is linear motion, okay, that is converted into rotary motion. Then what will happen is this power will be enough such that this is capable of rotating this 2 3 times at least. So that is enough for the next cycle. So only during the starting time we need to give the pedal, that is the first two stroke. After that, absolutely no need of the driver, no need of the starting pedal. In case of car, instead of the pedal, a motor is used, starting motor. Okay. See, now third stroke is coming down. We know power stroke. See, pulley. Now the gas has become now fumes. ಹೋಗೆ ಆಗಿದೆ. It has to be sent out of the chamber. This is called as combustion chamber. It is going now. See, now this has become open. It has gone. This is the fourth stroke, which is called as exhaust stroke. This, so it has taken four strokes, means four linear movements for one complete cycle. This happens once it is started, it happens automatically.
The longer the stroke of the piston, the larger the displacement of gas and air occurs in the cylinder. To propel that piston, we need to ignite a tiny bit of gas and a whole lot of air. This creates expansion inside the cylinder. The fuel delivery system consists of an air intake manifold, valves, intake and exhaust, a fuel injector, and a spark plug. A four-stroke engine is called a four-stroke because four up and down motions are needed to complete the cycle. In the first stroke, the piston travels downward as the intake valve opens and a mixture of air from the atmosphere and a metered amount of gas from the electronic fuel injector enter the cylinder. This is called the intake stroke. On the second stroke, the piston travels upward, compressing the air and fuel to make a highly combustible mixture. This is called the compression stroke. At this point, the spark plug fires, sending the piston downward from the expansion of the air and gas mixture. This is the combustion stroke. The fourth stroke is
Combustion stroke is also called as power stroke. Intake stroke is also called as suction stroke.
the exhaust stroke. As the piston travels upward, the exhaust valve opens to release the burned air-fuel mixture. When the piston reaches the top of this stroke, the intake valve opens and the cycle begins all over again. It takes one up and down motion or two strokes of the piston to create one revolution of the crankshaft. RPMs, or revolutions per minute, is how many times the crankshaft rotates within that minute. At wide open throttle, the crankshaft may turn at 5,000 RPMs, or a dizzyingly 83 times per second. Meanwhile, the piston traveled up and down 166 times in that same second. Want to see how fast that is? Now, that's fast. Let's see it again. Amazingly, the four-stroke EFI engine does this smoothly, quietly, and reliably for years and years of operation.
Now, few points. Okay. So the microprocessor should give the signal to the spark plug at right time. Okay, at right instant.
Is how many times the
See, at right instant. Okay, so that timing should be proper. So microprocessor will sense the position of crankshaft. Okay, position of crankshaft. After the end of second stroke, it will issue signal to ignite the fuel, means to actuate the spark plug. So that is one operation. Then another operation is for controlling or for mixing the air to fuel. Okay. See, when we press the accelerator of the engine, accelerator will be somewhere else here. Okay. When you press the accelerator, accelerator will be somewhere not in the with the engine. It will be nearer to the operator. But when you press the accelerator, the it will open the fuel pipes throttle position. It will get opened. Okay, that will be sent to the microprocessor. Okay, so microprocessor will understand to what extent the throttle position has opened. Accordingly, it will send the air required for that particular fuel. See, when we press accelerator, throttle valve will be opened. More angle of the accelerator means more. So the microprocessor has to see many functions. Okay, then not only this one. See, when we want to fix the mix the air with the fuel, that air should be hot. And again, how much volume it should be mixed with the air depends upon the temperature and pressure of the air. Temperature, pressure. So all these things are there. So in a short idea is given to you. Okay, in detail it is given here. I don't think you will study all these things, and this is also not complete. Complete operation means a lot many things. Mechanical students will learn, automobile students will learn it fully.